Hello guys, today it's Sunday, 12th of May 2019, and I wanted to show you how to generate checksums in the Java programming language. So if you want to generate checksums in Java, then you can use the message digest class that is contained in the Java security package. First thing I will do is create a new project. I will call it checksums, and here I will create a new package. By the way, I'm using Eclipse. You could use any IDE, it doesn't really matter. You can use IntelliJ, you can use VS Code, you can go without an IDE and just go with a text editor or something. Let's go ahead and just use Eclipse here. So now I'll create a class. I will call it MD5, and I want this class to give me a method that can generate the MD5 checksum value for a string, right? I will call this method, just call it off. So we want to generate the MD5 value of the string that it's put into this method here and return it. Alright, so now we need to implement this method. We can use the message digest class of Java, and then we can use this message digest class to get an instance of an algorithm implementation. And in this class we want to generate the MD5 value. So now let's just do this first so it doesn't complain anymore. Okay. What we can do now with this message digest instance is that we can fill the bytes of the string that we put in here into this message digest. And then we can calculate the digest value. And this will output a byte array. If we want to display this as text, for instance, or compare it to another MD5 value that is in hex format, then we need to convert this to the hexadecimal string representation. We can use the data type converter print hex binary method. Alright, and that should be good here. We are done with our method. So now we have implemented it, but we have not tested it yet. So we have not used the class and confirmed that it works. We have not written an automated test for it. I will recommend writing a unit test for any of the classes that you write, because the act of writing the unit test itself shows you where the flaws in your implementation are. So we need a test package here next to our source package and the test class. And by convention, it usually is the name of the class plus test. And here we use the test annotation, and then we can import the JUnit4 library, and then you have this annotation. And this basically lets you execute your tests. And obviously we have not run any code in the test, so it will just pass. We want to instantiate our class that we want to test. And now you want to test a method. Let's say you want to test the off method. Then you put in some value. Let's say hello world. So this is a good opportunity to rename this to happy flow. We're just testing this one case where everything works fine. The algorithm is implemented, no exception thrown. So what is the MD5 of hello world? So for this we can just check some MD5 calculator online and then input hello world, and here we have the MD5 value. So this is our expectation, and now we can assert this expected value is equal to the output of our off method. Actually, let me rename this to MD5, because from the test here we can see the usage pattern of this class, and we decided to call this method off. So if we call our instance MD5, then we have this nice fluent way of reading it, which is MD5 of hello world. Now we can see if this test works, and sure enough it does work. So we change it here just to make sure that it will also catch errors, and it will. So the implementation works. Alright, so we've implemented this class now. We have the opportunity to generate the 5 checksum of a string, and we could just use this in any implementation now. If I say create another package here and a main class with the public static void main string args method, then we can system out print line the MD5, and we can execute this, and sure enough we get a MD5 value. So our test showed us that it works. So now that we have implemented it, we can try to make it even better, right? So we could, for instance, make a Java doc here, and then we can improve the code here maybe. But it's fine actually. Let's look at the test again. Yeah, we can in the test just save us this declaration, this variable. Let's make it a bit shorter and snappier. And now now you could ask the question, how do I implement this MD5 to also accept input streams instead of strings? And we can do this. So let's just go ahead and create this overload. And sure, we can create this method. So let's say we have an input stream and we want to calculate the MD5 value. Then once again, we can create the message digest, and then we need to iterate through the stream. So we have the read method. So that way we can read every byte of the stream. And so we're going to use this method here. So here we can declare a byte array where to read the bytes to. Let's call this buffer. And yeah, here we can declare our size of the buffer. And obviously if we read to this buffer, we need to specify the length, the number of bytes to read from the stream. So let's go with this. And then this second parameter is the offset. So the offset tells you the start offset in array B at which the data is written, and B is this buffer. I think if you want to read bytes into this buffer, you should always overwrite the whole buffer, so you start at 0, so it's fine. And here then we have the same size as here. You can even make this a variable. Let's call it block size. Do like this for now. This can throw an exception, throw everything for now. So now we read the buffer. Obviously we have to do this multiple times until this is read completely. So if we use this while loop and say have the bytes read here, and then we say if that read returns the total number of bytes or -1 if there's no more data, then we can say read until it's -1. This variable we need here. And now we would just continuously just read the stream with this block size, copy the bytes that it read to the buffer, and then update our bytes read variable to the number of bytes that it was able to read from the stream. And at maximum, it's the block size. So then in here, we can update finally our message digest with the bytes that we just read. Yeah, and then we convert the digest and return it. So maybe this works. No one knows until we test it, of course. So let's call this happy flow string and this happy flow stream. And then we can essentially take the same test that we have here, but instead of supplying this string, we can pass in a stream. And in Java, you have this possibility of creating streams in the try with resources block. And this will make sure that if we open up a stream, that it's closed after we are done using it. So what this try with resources block is now doing is we create our resource, which is this input stream from this byte array input stream that we open up. And once we leave this code block here, the input stream is automatically closed. All right. So let's try this, and it seems to work fine. Just check that it catches errors in case there are some. Yes. So this looks good. Obviously you can do the Java doc here. You can maybe get this block size out of this method by specifying it as a constant like this. You can make a Java doc. And then you can put it here, delete that. Is there any other way we can improve this? Maybe you can just, if you find a way to improve this, then feel free to just comment to this video. Julio is not spelled correctly. All right, add it to the dictionary. That escalated quickly. So this generates the MD5 value for a given stream. So one nice thing that Eclipse allows you is you can hover over this, you can cursor over this exception and will tell you where it's thrown. So in this case, the IO exception is thrown when this read operation fails. Alright, and now we have nice commented code. Short and simple, I would think. It is tested. At least the happy flow is tested. Now you could also try and supply a null value here and then make some design decision on what to do when this input stream that you pass in is null. And then you can, in the test, create a test for this case where the user puts null into this method and test that. You can do all sorts of things. But I think this about wraps it up for today. Just wanted to show you this with the MD5 checksum value generation and offer you some insight into how I implement my code and how I try to keep everything tested and commented. Obviously don't write really long comments because you also have to maintain those. But you know, these are just things that you learn along the way on your career of becoming a well-rounded software engineer. You could implement with this message digest API a class that is more general, where you allow the user to generate a checksum and then, for instance, of the algorithm that you're using, like this. And then you could let him pass the algorithm in. If he wants to generate an MD5 value, you can do that. But he could also supply like some other algorithm that he wants to generate the checksum for. So these are things that you could totally do. But if you're fine with MD5, just leave it as this. Because you don't have to over-engineer stuff. You ain't gonna need it, right? So don't write code that you don't really need. If you see the need to generate lots of checksums with different algorithms, then of course change this to be more appropriate. Alright guys, so I wish you a nice Sunday. See you next time. Bye bye.